few words about where this software that we are talking about have come from. So back in 1994, Professor Ashby and his colleagues founded the Granta Design Company. It was to commercialize a material selection teaching project. During the years, we've had strategic partnerships and significant investments from international organizations like the ASM International. And in 2019, we became part of Ansys, the global leader in engineering simulation. And throughout all of these years, our vision has always been to integrate materials intelligence into education, research and development, and the product lifecycle. Ansys currently has 3 separate products to support academia and industry when it comes to materials, data, and management, materials data management. So within the academic environment, we offer Ansys Granta EduPack and Ansys Granta Selector, which can be used for teaching and research purposes. And you can see some of the universities that have implemented these 2 software in their curriculum. On the industry side, we have, again, Ansys Granta Selector, which is used as the gold standard for material selection in industry, and Granta MI, which is used as the platform for materials data management. And you can see some of the companies that have implemented these in their workflow. EduPack is currently being used in more than 1,400 universities all across the world, and our aim is to help academics build their students' materials intelligence. Fair question to ask would be if you have not had, if you've not been familiar with the software of what is EduPack. Well, it's a unique educational software that provides access to an encyclopedia of materials and process data, as well as powerful materials software tools such as visualization, filtering, and estimation tools. Academics who have access to the software can also use more than 240 teaching and learning resources that we have available on our website. These are case studies, exercises, lecture units, and micro projects, which enables academics to immediately start implementing the software in the classroom and help their students get familiar with material science and engineering. Okay, so it's not just the software, it's a package of software and teaching resources. Let's focus on the software bit for now. How the data is structured in EduPack, we have 3 levels of databases available in the software. In level 1 database, it is essentially developed to be used for introductory courses. We have about 70 materials and 70 processes data sheets available, and it can help educators in introducing students to materials and processes. Level 2 databases typically have a bit more information. So as you can see, we have about 100 materials and processes data sheets available there. It is designed for intermediate level courses and helps educators to introduce students to the role of materials and processes in design. Level 3 databases are, as you can see, they have far more information available there. These are on par with the level of information that we have in the software that we provide to industry. So there are more than 4,000 material data sheets, as well as 246 data sheets for manufacturing processes. These can be used, of course, for teaching advanced courses, also for project-based teaching and final year projects and master level courses as well. So we've divided the data and tools that are available in the software into essentially 2 rough categories of, if you're teaching on the introductory side of things, we have a version of EduPack called Ansys Granta EduPack Introductory, where you would have access to these data and tools shown on the screen. So in terms of the databases, we have dedicated databases for subject-specific courses. For example, if you're teaching about phase diagrams or the tetrahedral of material science and engineering, namely the relationship between processing properties and performance of materials. We have the interactive tools in the material science and engineering database that would be helpful. We have dedicated databases for teaching sustainability, bioengineering, design, and architecture. And on the tools side of things, the key functionalities of EduPack are available. So with the browse and search functionalities, students will be able to find information about specific materials, processes, and applications. With the chart select, they would be able to create visual charts and run material selection projects. Eco audit, which I will showcase in our live demonstration today, helps students to investigate the environmental impact of their choices when they're designing a product. And the data available in the software, of course, as Sarah mentioned, can be exported to Ansys and other CAD and CAE software if simulation is something that your students are using and interested in. If a bit more advanced teaching and project-based teaching is what you're interested in and what you're doing in your classroom, we have the full version of the software, which includes these additional advanced data and tools available. So we have 5 subject-specific level 3 databases available in the full version. These on top of the fact that, of course, they have those more than 4,000 material data sheets. They also have temperature-dependent material properties, as well as other curve data like magnetic pH curves, stress strain curves, fatigue strength curves, and so on. And the aerospace database, for example, is linked to the MMPDS and Military Handbook 17 data handbooks, which are industry standards for design allowables in the aerospace industry. And the polymer database, as another example, is linked to the global polymers database, which has more than 100,000 data sheets for different grades of polymers, where it provides attributes of those polymers in these data sheets. On the tools side of things, I'm just going to talk about synthesizer here. But of course, if you're interested, let me know and I can provide more information in the Q&A section. The synthesizer tool essentially allows students to estimate properties of hybrid structures. So if they're interested in finding out or predicting what would be the properties of a sandwich panel, multilayer materials, cellular structures, we have analytical models available in the synthesizer tool, which will allow them to investigate these. So on the whole, EduPack, as you can see, is being used at the moment in many different departments. So not just mechanical engineering or material science, but we have a lot of universities who are using the software as a essentially campus-wide resource where the departments that are interested in sustainability, manufacturing, bioengineering, civil engineering, they're all using it to teach their students about materials. And it is used across essentially the curriculum. So from beginning, when the students start their courses in year 1, right across the final year and the master's degrees. So briefly on the different use cases that EduPack can support educators when they're teaching about materials in their classroom. Of course, as mentioned before, it's a comprehensive library of materials, which includes more than 4,000 material data sheets. Academics would be able to visualize essentially material properties and help their students compare materials and categories of materials in terms of different attributes. There are significant self-learning tools available in the software, which of course enables students to keep their education running even when they're outside of the classroom. For example, we have a Learn Online section within EduPack, which enables students to learn a bit more about materials, material selection, different attributes of materials. It allows and helps academics to teach material selection quite easily and smoothly to their students. as we will see. And there are tools available in the software which helps students to understand the economic side of materials, and if they need to keep that into consideration when they're selecting a material or an application. As mentioned, the synthesizer tool helps them to estimate properties of hybrid structures, and the interactive tools in MS&E database helps them understand the relationship between processes, structure, properties, and performance of materials. And finally, the Eco Audit tool, which enables them to take into account the environmental impact of their material selection choices. To go further a bit on the sustainability side of things, of course, we are all aware that going forward, more and more it is important to teach the students about the life cycle thinking when it comes to everything in engineering, but more specifically on the materials science and engineering side of things, and thinking about eco-design. Because of, of course, the global warming challenge that we are all facing. And when we are talking about life cycle thinking, when it comes to materials, of course, we are thinking of the cycle that we have on the left-hand side of the screen, where students need to be conscious of where the materials are extracted from, and how that is done in the material production phase, and then the materials are sent to product manufacture, where essentially, as mentioned by the name, a product is being manufactured from those materials, and then the product is being used in a specific country for a specific amount of time. Is it part of a car, which is part of a moving vehicle, which needs the fuel to be spent on it, or is it going to be stationary? And then by the end of its life, what are we going to do with that product? Are we going to recycle it? Can we recycle it? Do we need to, downcycle it, or do we have no choice but put it in the landfill? So keeping all of that in mind when we are trying to select materials for specific applications, that helps students to take environmental impact into account as well. And we have dedicated databases and data tables in EduPack that helps students to and tools available in EduPack that help students to essentially learn a bit more about this life cycles thinking. Specifically, we have level 2 and level 3 sustainability databases available in the software. In both of them, the elements data table is available in both databases, which enables students to explore compositions of materials, as well as show their geo-economic and eco and criticality aspect. So you'll be able to see for a specific material, that element is being essentially sourced from a specific country, how much of that material is available worldwide, if there are any issues in that country. So speaking of that, we have the nations of the world data table available in both databases, which helps students connect materials to their sourcing countries. We have dedicated data sheets for each country, which explores the social and economic aspects of a country, and they can create interesting charts and informing charts like the one that we can see on the screen, which compares all the countries in terms of their electricity production per population as compared to the annual greenhouse gas production per population. So we can see that there is a clear trend that as the electricity production increases, the annual greenhouse gases production increases as well. And finally, we have the legislation and regulation data table available in these two databases, which allows students to bring context to current sustainability practices. They will be able to see for any specific region, what are the main legislations and regulations, and it supports corporate social responsibility teaching as well. Specifically in the level 3 database, we have some more unique attributes available. So for example, on top of the technical material properties that are available in material data sheets, we have information about if a material can be used and is used in food and health industry, if there are health hazards attributed to a specific material, criticality of materials are mentioned, and if there are any possible substitutes, if there are issues with that material. And we have a unique data table available in the Level 3 Sustainability Database, which explores power systems, including systems for generation and storage of energy, and you can see the different categories that are available in there as well. A few words about the eco-audit data, the tool, and then we'll jump into the software. So the eco-audit tool is one of the most popular tools available in the software. It directly allows students to explore exactly this life cycle of products. So it provides a high-level assessment of product environmental impact in different stages of its life. Students would also be able to determine if there are any dominant areas that are having the biggest impact on the environment, and they would be able to explore essentially alternative or what-if scenarios to see if they change a material or a manufacturing process or something within the use phase of the life of the product, how that would change the environmental impact, namely the energy requirements and the CO2 footprint of that product. So I'll show that in the live demonstration. The good news is, or one of the good news is that from essentially last year, we have kept increasing how academics and students would be able to customize the way that they work with eco-audit. So previously, students were only able to bring in the materials that were available in the software as part of this environmental assessment, this streamlined life cycle analysis that can be done with the software. But from last year, students and academics can use their in-house data. So if there's a material that is not available in the software, students can essentially create a data sheet within the software and use it within the eco-audit tool as well. And so, of course, that's very helpful to explore specific materials and manufacturing processes that you're teaching within your classroom that may not be available in the software. Okay, with that said, let's jump into Ansys Granta EduPack and showcase some of the things that we have talked about up until now. So these are the different databases that are available in the home screen of the EduPack software to choose from. We have the introductory, level 1 and level 2 databases on the left-hand side, and the level 3 advanced databases are available to choose from in the right-hand side of the screen. So for the demonstration purpose of today, I'm going to choose to look into the level 2 sustainability database. So let's click on that. So here we have the home screen of the level 2 sustainability database. On the left-hand side, we have the different data tables available. So for exploring different material data sheets, we have the material universe data table. If students are interested in different manufacturing processes, sorry, close that. We have the process universe data table. References include the different sources of data that we have used to gather and agglomerate this data. Producers provide information about producers and suppliers of these materials. The elements database, as mentioned, essentially provides information on different elements on the periodic table. And we talked about nations of the world and legislation and regulation data tables as well. Essentially, let me click on that. And sorry about this. In the middle of the screen, we have subsets of different materials that are available in the software. So for example, here we can see categories of composites, elastomers, foams, and so on. That's, you can find data sheets for materials within each category. And on the right-hand side, we have, for example, a link that would take you to video tutorials, which are short, between 3 to 7 minute videos that students can use to familiarize themselves with the general functionalities of the software. So I would say quite good self-learning tool for students to start using the software. And on the top, we have the main functionalities. So as mentioned, if students are interested in finding information about specific materials, processes, applications, they can use the browse and search functionalities. Let's click on browse. And here you can see that in this level 2 sustainability database, we have information in ceramics and glasses for hybrid materials, including composites and natural materials, for metallic alloys, and for polymers. So let's imagine that a student is interested in finding information about, for example, nickel-based superalloys. So of course, they would be able to go into the category of metals and alloys. Nickel-based alloys are considered non-ferrous. So we can see here that we have a folder for nickels and alloys, and there is a data sheet available for nickel-based superalloys. So let's click on that. And the data sheet for this material pops up, which includes images of components that have been created using this material. And we have a brief description of nickel-based superalloys, which includes information about, for example, the fact that these superalloys combine exceptional high temperature strength with excellent corrosion and oxidation resistance. And it also provides information about some of the elements that can be available in the composition of these materials that would provide those excellent properties. Let's keep in mind that this is a level 2 datasheet, so which means that we have one datasheet that is covering all of nickel-based superalloys. If we move on to a level 3 database, we would be able to explore specific data sheets for specific grades of nickel-based superalloys. Okay, let's move on. Here we have price and density of this material available, mechanical properties including Young's modulus, yield strength, Poisson ratio. If students are interested in finding information about any of these material attributes, and if they're not familiar with them, they can simply click on the information icon next to each attribute, and by doing so, a science note pops up. Which includes comprehensive information about the, in this case, Young's modulus, the background of the attribute, how it can be calculated or measured, if there are any other material attributes that are associated with Young's modulus. And at the bottom of the science note, we have a list of further reading that if students want to get, dive a bit deeper into this material attribute, they will be able to go into any of these textbooks and find that information. So I would say pretty good self-learning tool for students to familiarize themselves with each of these material attributes. Moving further down, we have information on the thermal properties, including melting point, specific heat capacity, thermal conductivity, information on electrical and optical properties of the material are available. Criticality of the material is explored, so whether the material would have supply chain issues at the moment or in the near future, that is explored. And how well the material would be able to be processed, how well the material would be able to withstand different environments, including water solutions, acids, alkalis, oils, alcohols, and so on. We also have information about the environmental attributes. So, for example, embodied energy and CO2 footprints of the primary production of the material, as well as its those same attributes for different processings of the material are available here. At the bottom, we have the essentially end-of-life attributes, which, for example, has information about whether a material can be recycled or not, and if it can, what would be the environmental impact of that recyclability that is mentioned here. We have environmental notes, design guidelines, technical notes, and typical uses of this material available. We also have in level 2 databases, if relevant, the corner of the essentially, or the part of the phase diagram that is relevant to that material is mentioned here. So at the bottom of the page, after talking about typical uses and trade names of this material, we have links that would take students to other parts of the database that has information relevant to this specific material. So for example, if we go to the link for Process Universe, we can see all the different processes that are compatible for joining, shaping, and surface treating this material. For example, if we go into casting and investment casting, you'd be able to see that we have a dedicated data sheet for manufacturing for this specific manufacturing process, which again, similar to the material data sheet, I'm not going to go through this. It has information about the description, schematic of the process, what are the shapes and materials that would be compatible with the process, and so on. Okay, in the interest of time, let's move on to the chart select functionality, because search is straightforward. Students can search for a term and the software would bring up for them relevant data sheets to the term that they are searching for. But for chart select, this is the functionality that enables students to create visual charts and run material selection projects. So in this demo, I'm going to focus on creating a visual chart. If you're interested, we can explore material selection either in the Q&A or separately after the webinar. So in order to create visual charts, which would help students compare materials and category of materials in terms of different material attributes, students can simply go into the chart select functionality. As you can see, we are directly in a selection project, and we can click on chart index. The software asks us to populate the Y and the X axis. So just to continue on the sustainability side of things, I'm going to populate the Y axis with the energy requirements. So let's go to primary material production and embodied energy of primary production. I'm going to have that attribute on the Y axis, and on the X axis, I'm going to have CO2 footprint of primary production. So there you go. We have the option to be in the logarithmic or linear scale. Let's click on OK. And the visual chart comparing materials in terms of these two attributes pops up. We can click and drag to label any of these individual bubbles that are essentially dedicated to a specific material. So you can see on the top right corner we have gold, and on the bottom left corner we have limestone. We can also visualize the different categories of materials. So let's click on show family envelopes, and here we can see we have metals and alloys, composites, natural materials, non-technical ceramics, glasses, polymers, and so on. So students would be able to easily and visually and interactively compare materials in terms of their attributes, and this would enable them to move forward. For example, if they are trying to select a material for a specific application, this could be a good starting point. Okay, so very briefly on how to create a chart and the typical structure of material and process data sheets. But the other thing that I wanted to showcase today was the Eco Audit tool. So very quickly on that, if we click on the tool, in the interest of time, I'm going to open up one of the samples that are provided to students as part of the software. So let's look into a product, for example, the bottle PET product. As you can see, what students can do is that for a specific product, they would be able to fill in the bill of materials for that product. So different components, in this case, the bottle and cap and water are separate components. The students would be able to select the materials that they have in mind or that are on the market for these specific components. So for example, for the bottle, we are using the PET material polymer. They would be able to choose whether it's a virgin material or it's essentially partly if it's a reused part, or they can also identify a percentage that is recycled. So they can say, for example, 50% of the PET polymer used for this component is going to be sourced from recycled sources. They also need to identify the mass of that component, how it is manufactured, so they can choose the different manufacturing processes that is being used. And as I mentioned before, they can add a custom process. So if the manufacturing process is not available in the drop-down menu, they can add their own process if they have the information about the essentially environmental attribute of that process. And they need to identify the end of life scenario for that component. Is it going to be recycled, downcycled, combusted, or landfilled, or so on? So that's the bill of materials that they need to identify. Then if there are any transportation needs required for that product, so for example, transporting it from, in this case, the filling plant where the water is going to be filled into the bottle, to the retailer, there are different transport types available here, all the way from aircraft, different types of aircrafts, to trains, trucks, and ships and ferries and so on. So they can select that, and they also are required to put in what is the distance that the product is being transported. And for the use phase of life of the product, they can identify how many years it's going to be used, in which country, which has an effect on some of the products because the energy mixture used in different regions of the world or have different environmental impacts. And they need to identify if the product is a static product. Is it going to be a essentially a guardrail that is going to be sitting on the side of the road for the entirety of its life? Or is it going to be a car bumper, which is going to be traveling with the car and fuel needs to be spent on essentially transport of that specific part? And there are other attributes that they can identify here. When all of this is identified by the students, the software, when clicked on summary chart, would essentially inform the students about how this product would impact the environment in terms of its energy requirements in different phases, as you can see, for material, manufacture, transport, use, and disposal, how it is what would be the energy requirements, and for the CO2 footprint of it. For different phases, they would have information on this. They would also be able to explore what if scenarios. So if I, for example, here go to the top and select compare with, copy of current product, I can change a specific material or manufacturing process or any of the other inputs here, and I can see how live this would change the environmental impact. So for example, if I change the polymer to a glass, for example, glass, let's go with soda lime glass. And of course, I need to change the mass of it as well, because glass is much heavier than the polymer. So let's go with 200 grams. And I also need to identify the primary process. So let's go with glass molding. And we can see when changing from PET to glass, the green bars are for PET and the yellow, let's call that, bars are for glass. We can see that on the material phase, the environmental impact or the energy requirement and the CO2 footprint for glass is much higher, or higher than the PET. And of course, more material is being used here. That has an effect here as well. On the manufacturing side, again, glass has a more environmental impact here, similar to transport phase, again, because it's heavier. Use case is similar. Disposal, again, glass is not as environmentally friendly as PET. So students would be able to immediately see how changing a specific parameter in the life cycle analysis that they're running would change the environmental impact of the product. And so, yeah, this would hopefully inform them and inform their decision-making process as well. All right, let's go back to the slides and finish up quickly by going through some of the updates that have happened in the recent years. So in 2021, we added some data and tools available in the software. which allows students to explore battery cells and different attributes of different types of battery cells, and they will also be able to use the battery designer tool to combine different battery cells into a battery module and then a battery package, battery pack, and see how the performance of that modular pack would be different if the settings that they're using to create that modular pack changes. We've also done a complete refresh of the built environment database. So if architecture and civil engineering is of interest to you, we have a lot of new images and essentially updated information on the material attributes there. From 2022, students are able to create their own category of material bubbles. So you can see here, family of each material family is being shown to have an envelope here, and I showed that in the software. Custom material bubbles can now be created, and that can help in specific projects that you might be introducing your students to. They can create their own specific categories of materials that would be relevant to the course. As mentioned, from 2022, students can use their in-house data on materials and processes within the Eco-Audit tool, and we regularly add exporters to EduPack that would enable students to use this data within CAD and CAE software if they're running simulation. This is not just Ansys, there are other software, Abacus, SolidWorks, MathML, all of them have their own dedicated exporters available in the software. Specifically this year, we have essentially integrated the medical devices database that was a standalone database into bioengineering to streamline teaching of these type of courses. Students can create and use their own transportation as well, not transportation, sorry, secondary manufacturing processes within their Eco-Audit tool, so even making the tool more customizable. And the whole of the sustainability attributes available in the software have been updated. So it is completely essentially updated information available in the software in that regard. Very briefly on the teaching resources that are available for the academics when you do have access to the software. These are, as I mentioned, teaching essentially resources that would help you implement this usage of the software immediately in your classroom. They include lecture units, case studies, exercises, micro projects, white papers. There are more than 240 of them. And I've included the link here, which you can use to go into the Ansys Education Resources website. I would say more than 80% of them are open use. So you can essentially use them without any essentially permission required. Some of them are reserved for educators that have licenses of EduPack, because we typically don't want students to have access to them because they have answers to questions. So there's, for example, sets of exercises with answers, which academics regularly use for creating assignments and exams. So we don't want students to have access to those answers. These are some examples of the case studies and micro projects that are available in the website, specifically for material science and engineering, mechanical applications, bioengineering, sustainability, so on. Ansys has what is called innovation courses. These are free courses on our website, which we have for different physics that Ansys has tools in. Specific for materials, you can see that we have 7 Ansys innovation courses that students can use to inform themselves about materials, material selection, material properties, structure, performance. This can be extremely helpful as a self-learning tool for students to learn a bit more about materials. And I've included the link in the slides as well. And I think this is my last slide. So we this year have a material selection competition. which if your students are interested, get in touch with us. They can, essentially the professor can be the representative of a group of up to 3 students. They can send a proposal to Ansys of what application they would like to select materials for, and then they essentially are competing with hundreds of other student teams. There we provide prizes to the winners of this competition, hundreds of euros. So I'm gonna put it like this. And yes, so if that is of interest to you, students would use EduPack to run material selection projects. They can, as a bonus, include simulation in this, these type of projects. And please get in touch with us, and we'll be happy to have your proposals as well. Okay, so I'm gonna hand over to Sarah. I'm sorry, I think we are running a little bit over time as well, Sarah. So maybe we can just do the recap and go straight to the questions as well.
Yeah, of course. So indeed, yeah, I hope this was very helpful for you to learn more about what EduPack has to hold. Naveed, you can go to the next slide, and maybe the slide after that as well. I think that will be more
Should I go to the
helpful.
next one?
Yeah.
There you go.
Yeah, thank you. So here you can find the contact details. We have, of course, our general information, but you can contact me directly as well. I'd be happy to help, to advise you, to see what is possible, to open all the doors that are, that allow you to use Ansys and Granta within an academic environment, because the opportunities are endless. And next, I want to shine a light on 2 upcoming webinars. So I mentioned it before, within the optics region, Ansys has really developed a lot of new tools. And next week on Thursday, we have an additional webinar to go over that specific tools, which are also, again, available in the academic program. So should you have any interest there, please feel free to join our webinar. And in April, 19th of April, we have an Ansys webinar, very specifically on how to implement simulations within different academic courses, which can also be very helpful on having that first insight on how to implement simulation. I think we can close it off here. You can click one more time, Naveed, and it will show just if there are any remaining questions. I think, see, now everyone can unmute themselves normally. So should you have any questions, please feel free to ask them. If not, I thank you a lot for joining. We will send you all the information that was discussed today. And if there's anything else that you would like to know, please reach out to us, because we're very happy to help.
I think there is a question panel, but you don't need to put anything in there. If you have questions, feel free to unmute yourself as well. Yes.
Mark says, thank you very much. Great webinar.
Pleasure.
Okay. Yeah, I think maybe it's some food for thought, and the questions will come. I'm happy that we reached everything within the hour, and we will send all the information to everyone attending. And if there's anything else, we're here. Okay.
Yes.
I thank you all. Thank you, Naveed, and we'll talk soon.
Of course. Pleasure, Sarah. Thank you, everyone. Have a great day.
Bye.